I'm just going to introduce this panel. This panel is called Don't Trust, Verify. And we have a bunch of experts here who will talk about that. So perhaps you guys would like to introduce yourself. Mark?
Yeah, sure. My name is Mark Friedenbach. I currently work with Digital Garage Labs, a Tokyo-based research group. And that's about half my time. The other half is spent on various open source projects with a focus on adding extensions to Bitcoin and Bitcoin-like protocols through soft forks. Probably what I'm most known for is the work that I've done there on things like absolute lock time and other smart contracting improvements.
Well, I think we've already introduced ourselves through previous talks, but in the context of this panel, I should say that I consider myself an independent Bitcoin developer, and I think it's everyone's responsibility to verify the code that they run and what software they use.
Yeah, I agree. Okay, so let's go straight to the first topic then. What do we mean by don't trust, verify?
Well, and there's two aspects to don't trust and verify. One is the amount of trust that you put into the software projects and the outputs of the software projects that you use, and how much verification you can do locally. These are actually separate issues because, as we learned earlier with a great talk by Carl on the build process, it's very, very difficult to extract out trust entirely from the architecture that we use for building and distributing our software products. So there's ultimately, in the near future, still a little bit of trust somewhere, and you have to, as both DevOps people and maintainers of infrastructure and as end users, we need to be aware of what things we can do, what responsibilities we can take on to verify the source of the information that we use. And part of my interest for being on this panel was that I see a lot of failings in the systems that we have, a lot of which are based on GPG for signing and validation of code. And the model that is presented there is often at odds with what we need to use in order to make our software secure. It does not support very well multi-signature validation. It does not support any kind of complex key rotation schemes or link in very well with our hardware wallet ecosystem. So maybe we'll touch a little bit more on that
Later.
Well, Don't Trust, Verify is primarily a t-shirt marketing campaign to sell t-shirts. No, actually, one interesting aspect of Don't Trust, Verify is actually the idea of verifying Bitcoin blocks. In the Bitcoin protocol, it is absolutely important that you run a full node that verifies all of the data and verifies each block in every transaction. If you don't do this, then how do you know that a miner isn't stuffing a block with fake transactions or inflation or doing other invalid things? So that's another important aspect of Don't Trust, Verify.
So perhaps it's because I come from like that operating system background. I'm very concerned about the security of the supply chain, all the way from the hardware and like the operating system tool chain, how the binaries are distributed and verified by the users. Like we learned a lot from Carl's talk. It's like finally we will. Like we're not too far from having a bootstrap tested and fully reproducible build environment in which you can build anything else, and like that is a major improvement over anything we've ever had in software distribution, in all these decades of software. Now, when it comes to GPG. And the other ways in which your binary downloads, like for Windows and Mac, are signed. It only protects the user to a certain degree because, like, by verifying the signature with GPG or the equivalent on Windows or Mac, you're really only verifying not that it doesn't contain malware, but that it hasn't changed since it was signed. And in this future where we can do reproducible builds with a build environment that we have a fairly high confidence that it's not compromised, then you as users, if you're paranoid enough, or if you're operating a service where the stakes are high enough, you don't need to rely on GPG at all to verify that your binary is safe. Instead, the ease of use of using the reproducible build tools, you don't need to be a coder to verify. But okay, maybe it is a little time consuming to go through the reproducible build process yourself. And then I would say, again, the same word, diverse verification, but in a different way. It's like the reproducible builds distributed by bitcoincore.org, for example, has like 5, 10 sometimes independent persons who have done the build process. They're all identical and they sign with their GPG key. So the next best thing to you building it yourself to verify is to verify the signatures from 10 independent entities, and you hope they really are independent. Like in my case, I've met them personally, so I think they're independent.
So I think you should actually verify the signatures and do the reproducible build.
Yeah.
Because otherwise you're doing reproducible malware, as Carl mentioned. So
yeah. So it largely depends on the stakes of like if you are a service provider where a lot of money is on the line, it is not that time consuming to ensure that at least that one problem is defended against. And thanks to the efforts of especially Carl, also Corey Fields and others, like those tools are getting a whole lot better and easier to use for everyone. You do not have to be a coder to do the reproducible build. Like there are great documentation to do it right now.
Okay, so just to reiterate, you're saying that reproducible builds are probably a better alternative to checking the GPG signature of the things you verify. Yeah. Okay.
It truly lives up to don't trust verify in that way. While checking GPG signatures is literally trusting someone else.
Yeah. Okay. Maybe we should talk a bit about the problems of GPG or PGP rather.
Right. So the PGP system, of which GPG is our main open source version that we use, is fundamentally stuck in the 80s and 90s in terms of its structure and what it supports. It's assuming that we're using a signature model like RSA or something that supports similar features, and that we have single signers who have keys on their laptops or computers or servers and use that for hot signing. And it has a built-in Web of Trust model, which is a bit ahead of the time for what it is able to do. However, the Web of Trust model doesn't allow you to do things like have complex post-facto key rotation schemes that are announced and distributed to users when they happen, or being able to timestamp creation of keys so that you can tell whether something really was a key that existed 2 years ago or whether something that was created just a minute in the middle of you 10 minutes ago. These are things that the protocols don't support very well, and none of the software that we use for doing in this kind of verification has any hooks to support as well. So I'm hopeful that this is changing. There are people in the rebooting Web of Trust movement who have started working on things called identity wallets. Identity here, I think, has taken on a bad name. I prefer to call them trust anchors. If you want to validate the signature of a reproducible build, that's great, but where did you get the public key that you're validating the signature against? And how do you trust that? And that's what rebooting Web of Trust is attempting to fix. So as we see more of these capabilities come online in our identity wallets, I hope that we can transfer that into the trust that we have in our software. And I also hope that the direction of development can go back the other way as well, that things we have developed in the Bitcoin ecosystem, we should be applying into our key management for reproducible builds and code signing. For example, people generally don't treat the keys that they use for code signing with quite the same level of security that they do the keys in their Bitcoin wallet. And in some sense, that's backwards. It's far more dangerous if the launchpad key that is used for signing the Bitcoin PPA is compromised. Everyone's wallet is affected in that case.
Well, specifically, let's describe that problem in broader detail. The problem here is that so Bitcoin Core has this Gideon build and has reproducible builds, and that's a good idea. It can be further improved. That's great. However, the way that software development works for most companies that use Linux-based operating systems for whatever software they're running online, like different web apps or something, exchanges and so on, often, if they're using something like Ubuntu, they have an incentive to just go and directly use the PPA on Launchpad and download the Bitcoin binary from there. The problem with this, though, is that Launchpad actually rebuilds the Bitcoin binary on its own system, and as far as I know, the hash doesn't actually match the Gideon build hash.
No, it's not currently set up to do that. So if you download from the PPA, then you're trusting basically Canonical, that they built it correctly on servers that they control and that you trust.
Ideally, individual Bitcoin companies should always use Gideon builds and build things themselves. Trusting this to Launchpad and Canonical is just way too much.
But even if we accept the reality that a lot of users are going to be in a situation where they just want to get stuff done and adding a PPA to their Ubuntu install is the easiest thing to do, it could still be the case that upstream infrastructure, like Launchpad in the case of Ubuntu, could be configured to accept multiple keys, a key from the software author or multiple authors, and a key from Ubuntu's infrastructure as well. And for the Debian package you download to be valid, it has to have a valid signature from both. And we are seeing movements towards this direction from the Fedora project, from the Debian reproducible build project. But there needs to be a much stronger push towards having this capability, and I think the use case for it is in wallets and getting access to secure wallets.
So specifically on Fedora, I worked on that from 2002, and I'm not involved in the day-to-day in that project anymore for a long time, but for years now, I insisted Fedora do not ship Bitcoin for like various security reasons, and like I would recommend to them to wait until this new reproducible build system based on Geeks, as Carl's talk outlined, is ready, and to distribute only an identical build to upstream because the quality control and the verification is a lot higher than. And I similarly would recommend like especially if you are a service provider in cryptocurrency, like there is no room for mistake. Any mistake as a result of human error or malicious code is irreversible. And if you use like this new build system based on Geeks to make all of your internal applications that are deployed reproducible, then this is also a way to guard against insider attack, like either accidentally or intentionally. I've known of like DevOps or release engineers at companies whose machines are personally compromised, and they had and the attacker from the outside was able to cause a lot of damage as a result of pushing compromised binaries to the internal infrastructure. But like there is a exact way going forward for those who develop and those who build and those who deploy can independently verify that there's no unexpected code in the binary that doesn't match the source.
Okay. Do you have any thoughts for Windows or Mac or other OSs?
Well, for Mac, someone in the community came up with a scheme, either complete or perhaps partial, for having some sort of way of doing multisig signing of Mac binaries.
Actually, Bitcoin Core already has, it comes with tools in the source code to verify the signed version against the unsigned Gideon binary. I know that's sure for Windows. I'm not sure about the Mac build though. Yeah.
Okay. But ideally, we'd be moving to the Gideon builds on Windows and Mac as well.
We currently do, but
Encouraging people to use it and build it themselves.
Oh, certainly, yeah. So if you do a Gideon build, it'll output Mac and Windows binaries, but they're not code signed. So obviously, one of the difficulties if you've run any computer running Mac OS or Windows in the recent years, it's very difficult to run a binary that is not code signed by Apple or Microsoft. So you end up being put in a position of being forced to use one of these built binaries. Now, the binaries on Bitcoin.org work fine. I think what Bryan was alluding to was the ability to do multisig or other forms of multiple source authentication for the signing of these binaries. Instead of, you can do the Gideon build process and then one developer somewhere pulls out the secret and signs it. And there's still a central point of trust there. And in principle, it's possible. The crypto choices that were made by both Apple and Microsoft are not as amenable as, say, our SecP Schnorr signatures would be to doing this kind of signature aggregation. But it is possible, just like it is in principle possible to do N of N Bitcoin ECDSA signatures. It's just very difficult and time consuming. I would hope that by moving into having accepted standards in W3C and elsewhere, IETF, for rebooting Web of Trust primitives that include programmable signatures, we can start to have major upstream vendors like Apple and Microsoft include in their hardware trusted crypto environments primitives like Schnorr SecP and others, so that we could do more complex code signing than we currently can.
It's worth pointing out right now that, if there is a download site for like Bitcoin Core, for example, even though those binaries are signed for Windows or Mac to more smoothly install, nothing stops any third party from verifying that against reproducible builds and then setting off an alarm if it doesn't match. So like there is no new tech needed for this to for there to be like a yet more community-based defenses.
And they're not at odds with each other, reproducible builds and code signing. They're coming at it from different directions. If everyone is attempting to reproduce the builds themselves, then when there's a problem, it becomes discovered and it becomes a major issue. And so it keeps bad actors in check, because if they were to attempt an attack, man in the middle, a download or something, they would be caught, or have a high likelihood of being caught. And the other end of it is, of course, securing your own distribution. Even if you're building it yourself, you still are sourcing the source code from somewhere. And so how do you trust that? These are two separate problems, both of which need to be solved.
Yeah. What else should we? You have anything else to add, Bryan? Okay. What do you think of this? Maybe the commit access fallacy that we had a bit earlier. It was mentioned in the talk. Maybe we should elaborate a bit on that. So if there'd be an attack that somebody forces one of the maintainers to add code.
Okay.
To.
Yep. So outside of those who have been part of a especially open source peer review project, especially in safety critical projects in which there are many contributors around the world, also the Linux kernel is an example of this. It's like you being a moneyed interest or with political power, that is not a legitimate reason to force your way to get some change into the code. And there are a lot of people who would fight attempts like that to force code changes that are for any reason other than it improves the software and it has passed the quality control process. It's easy for people outside of the software industry to make a big deal about commit access as if they are a gatekeeper, and I think some of them imply that it is a political process. But what would actually happen if someone unilaterally pushed their way, especially now in this project, is that many others would cry foul, and the legitimacy of that repo would then be in question. And it's highly likely that most of the developers would move on to a different repo and continue under the same process. And I'm just guessing right now, but I think that's what would happen. So it really doesn't matter who has commit access, because that does not give you permission to do things against the quality control process.
Right, and in fact, in the UASF adding SegWit to Bitcoin, that actually happened outside the core process. There were many core developers who were against it. That could be another example.
Even furthering that example, I believe the UASF was actually a pull request made against Bitcoin, and it was not merged.
Yeah, it's closed.
So I noticed some very interesting history with regard to UASF and Corp in particular. It's there was a lot of especially users begging Corp, please decide on our behalf. And the implication there is Corp, please merge UASF. And I remember there was one public weekly IRC meeting in which this was discussed. And the consensus then was, at the time, half of the core developers were in favor of UASF now, some were in favor of UASF later, and others thought all of this was too dangerous. But it didn't matter what any, it's not majority vote that decided not to merge UASF in the core. Rather, it was, this is clearly a potentially dangerous thing to do, and Core needs to err on the side of caution. And I thought that was a tremendous example of discipline in a safety-first culture. You need to err on the side of no change.
I had a somewhat different interpretation of what I saw at the time. Which was that there was a debate about whether or not to implement the UASF code in Bitcoin Core. I think the people who wanted it in was not calling for the Bitcoin Core developers to make a decision on it, which of course goes against the idea of UASF. But it's more that a lot of companies and a lot of individuals were in positions where they weren't able to build Bitcoin Core themselves, or they were unwilling to do so, and they were trusting the binaries available from the core team. And what the UASF advocates wanted was simply the ability to have a flag, perhaps off by default, for enabling it in official binaries, so you didn't have to build your own. And that did not happen. And so I think it's a fair question about how.
No, it didn't.
No, it did not.
Sure?
Even that was deemed too dangerous.
Yeah.
I saw there was another website that was distributing patched core with UASF.
They had nothing to do with
There was someone unrelated.
Yeah.
It was doing a Gideon builds with that patch, but
Yeah.
it was not the Bitcoin Core group.
Well,
So I think there is an unresolved governance issue there, which is whether the core developers should be gatekeepers in the sense of rejecting patches, and saying that this is too dangerous, it's not going to be in a core binary, even behind a off by default flag. And I think that has still been left unresolved since that time. And I can see both sides of it. I can't sit up here and pronounce one side better than the other.
And we're talking about consensus rules of whether SegWit should be. This is also, all the security stuff is obviously important for miners. You could imagine a situation where miners get their computers hacked and they're used to attack the network. So it's not just the validation side, but also the transaction ordering.
Well, in fact, miners have been attacked in certain ways like that. I mean, there are all sorts of BGP hijacking attacks against Stratum protocol and all sorts of weird things. Yeah. In fact, the Stratum protocol doesn't include authentication as part of the protocol.
Yeah, that's right. Yeah, I don't know how much time we have left. Is there any other topics we should cover? No.
I certainly would like to get some questions from the audience if there are any, or we can.
But before we get to that, do you remember BAD 32, the PGP thing about the 32, the short PGP key fingerprints?
Well, you can.
Yeah, anyway.
Yeah.
You shouldn't use short PGP fingerprints. You should use
the 32-bit ones.
Yeah.
Yeah, they can be grounded.
Oh, yeah. So I tweeted today a historic example where somebody made a matching, like the end of the GPG fingerprint with the code signing key used by earlier Bitcoin builds. And if you check only the last 8 characters, you could very easily be fooled into using the wrong key.
Well, and if you want to find a collision for one of these ahead of time, it's not that difficult. So I only see 64 bits of info there. So be very careful and follow best practices when it comes to verifying fingerprints and building your web of trust. I will make a call out there to one project that I'm very hopeful to see advance, which is the Bitcoin DID, Decentralized Identifier project out of the Rebooting Web of Trust, which provides a mechanism for doing key rotations and timestamping them using Bitcoin transactions. So in principle, anyone following the Bitcoin blockchain would be made aware of a key rotation when it happened.
Yeah.
So one other completely different don't trust verify like mistake that I've seen out in the community quite often is like wallet security. There had been a very popular privacy-focused wallet, that's how they marketed themselves for years, that used, like say good transaction graph confusing strategies while reporting all addresses to centralized servers for the past 3 years. So like be careful about claims that you see out there. That's all I have to say.
All right, let's get some questions from the audience.
So, well, with digital signatures on the source code and then building, if let's say if you download the source code and compile it yourself, you don't have to trust the binaries. You may still have to trust the build system, but we are working on that. But you still have to trust the source code, and you can check a signature on the source code. But then you only know that a certain person stands behind the source code. And now you can do code review, all kinds of analysis, but I think that's really, even for a developer, it's really hard to review a large code base. Is this a fundamental problem, or what is your view on this?
So you're talking about actually reading the source code?
Yeah, and reviewing that there's nothing wrong with it, that it is secure, there are no backdoors, that sort of thing.
Well, before answering the meat of your question, I mean, first of all, it's important to realize that in the Git protocol and Git system, it's actually possible to spoof commits from anyone. You just set your name to whatever you want and your email address to whatever you want. So the signature is still very important for authenticating that it's coming from who you think it's coming from.
Although you can sign Git commits.
Yes, and in Bitcoin, the commits are signed. So, yes.
But I think it goes a little further than that because most people probably don't have the developers' signatures in their GPG keyring unless they are developers themselves. The one great thing is that we're using distributed version control systems that have hash trees built into their very structure. Now Git uses SHA-1, we should retire that, but in principle it allows us to do things like call up your friend and say, hey, pull the changes in and make sure you're getting only a fast forward and tell me what the current tree hash is and compare that against yourself. Or in principle, a lot of the developers that I've worked with recently in these projects have had automated Git hooks that would sign and then open timestamp every commit that they make. And these are things that if there was better tooling and infrastructure, you could use to leverage your web of trust to decide whether you trust a repository that you've pulled.
So, but then fundamentally you are still on the trust side, not on the verify side.
No, this is not a two-sided thing. You cannot get rid of trust short of opening your own semiconductor fabs and electron microscopes. There is trust built in there. We try to trust minimize, and we want to have the least amount of trust possible and the simplest to verify and most democratically verifiable trust. And so things that have distributed validation properties like Git, where everyone has a copy of it, as opposed to a centralized version control system, are preferable. And we should leverage those advantages to help make sure that we're not losing those decentralized properties any step along the way. Great that the Bitcoin code repo is decentralized with Git, but then if you're just pulling binaries from a PPA, then you've lost any benefit that you had there.
Controversial opinion, but maybe people should read the source code.
Well, one of the flip side of it is that being open source, the assumption is that a lot of people are reading the source code, and that if there were, divergent code repos where one had, malware put into it, people would notice if that got pushed onto GitHub or something.
On that topic, it's really important that if you are using software for larger and larger service provider to look into the the level of due diligence that has gone into the engineering of that software and their ability to maintain it. The example that I had in the talk of talking of harm reduction. It's like a lot of people, they really wanted an address index. It's not the recommended way the Bitcoin developers would have people use Bitcoin, but a lot of people want to use it that way. And because Core didn't have an address index all these years, they used far worse solutions like Bitcore that became extremely expensive and still to this day does not support SegWit. And it's dangerous abandonware that is expensive to move off of.
I think.
Hi. The verification part of don't trust verify. If I verify a signature, I do all the steps correctly, but I don't understand what I'm doing. So it's basically security theater. Do you think this is a big problem, or is it? What do you think we should do something about that, or how do you educate people in verifying software?
Well, I suppose the only thing you need to understand is that if you get an error with verification, you shouldn't use that software. So I don't know what you guys think, but I'm not sure it's necessary that you understand the crypto.
It goes both ways. This has tricked people into believing a certain someone is Satoshi because there's a little sleight of hand on step number 37 when you substitute one hash for another. But the final step said verification okay, so it must be right? No, we have to make sure that all the steps are followed when you verify, nothing's skipped over, because that can be manipulated and used to subvert the process. And the only really way I see of doing that and making sure that happens is through building better infrastructure and through building common protocols supported by multiple vendors on hardware platforms for doing this sort of verification.
Yeah. What I was talking about is more like people following instructions on how to verify software blindly. Is that a problem?
Yes.
So fundamentally, this goes back to like even deeper issues in our society of like, how do you know anything at all? And how are you sure that these are the correct steps? These are very important questions. I don't know if I have any answers for this, but I mean, more education is certainly part of the answer.
I mean, as everyone knows, the way you validate software is you download it and then you SHA-SUM it and see if that's the same as what the website you downloaded it from is saying, of course. That's what everyone does, but that doesn't prove anything. It just proves that they put their own hash on there. And so we can come up with better and more complicated schemes for doing verification, but we live in a world where people were going to just trust what the website said in the first place. And so I think the only way to really solve that for 99% of the cases out there is to have very simple and easy to use infrastructure built in for making these checks. We're getting that infrastructure built into mainstream operating systems like we talked about before with Windows and Mac OS and iOS obviously from the beginning requiring code signing. The only problem is that these are completely centralized solutions. So we need to build out common protocols for doing the same sorts of things, but in a multi-sig aware, a multi-source authenticated way, and have those be adopted broadly, perhaps first in the Linux and FreeBSD ecosystems. And then hopefully we can push these standards out elsewhere through browsers until eventually Apple supports it in their touch bar chips and such.
Right. Hi. My question is about the hardware level, like machine level. I see, Mark, you have a T-shirt on with the RISC-V logo. I would like to ask that how close do you think we are to have like a commodity open source hardware?
Right. So while I was at Blockstream, which I left a little while ago, but while I was there, I sat on the RISC-V Security Working Group committee, trying to make sure that RISC-V in particular was making positive steps towards having both verifiable hardware in the sense of very easy to check, if you had an electron microscope, very easy to check that what you're getting was actually what you anticipated, but also developing standards for doing things like burning in security keys from the user side. So when you get your chip, you can then burn in your root level keys as opposed to having the Intels of the world set up their own keys and then license your ability to use the secure enclaves. So having a more open infrastructure for developing secure enclaves and hardware features on chips is a good direction to go. Unfortunately, we don't have a lot of very competent people working in this space on doing that. There is really just a handful of them. And without naming names or companies, a lot of time on that security working group was spent educating very highly educated people coming in from big name semiconductor fabrication companies that had no idea really about security. And their model of security was, well, there's this wire that once you activate, will allow you to debug and control all memory so you can verify it yourself. But obviously that just means an attacker could come in and JTAG into that wire and mission accomplished. So having people who are security conscious involved, not just in RISC-V, but all of these open architecture or hardware architecture systems is good. I think developing cross-vendor compatible standards for Bitcoin hardware wallets is where this is going to start. We begin with things like treasures and ledgers, and eventually we end up seeing these things in stuff like the HTC Exodus phone, where this is now getting mainstream and available in commodity mobile handsets. And by being very vigilant and involved from the very beginning, by giving positive feedback to these companies, telling them that they're doing good for going down this path, and then politely correcting them onto something that's more user-controlled and user-centric, is how we're going to accomplish that goal.
Thank you.
Any more questions? There's one.
So if I'm an individual user and I'm already running a Bitcoin Core full node, I'd like to get the panel's view on if I was going to run a second full node for redundancy. Should I run an old version of Bitcoin Core or should I run one of the widely used alternative implementations?
Depends on what you're doing. A lot of companies, as a first line of defense, a lot of companies will run the most recent release from every major release that's still supported of Bitcoin Core. The main reason why people do that is because we got bitten back in 2013 by that exact problem when .8 and .7 diverged. And so run the supported releases and check to see. But at the same time, there's been major companies that have also failed because they're using a Ruby implementation of Bitcoin instead. The one I'm thinking of in particular no longer does that, but for a while, they would diverge somewhat frequently from the main network because of some flaw in their system. So it really depends on what you're doing and who you're working with, and everything that's relevant you should be running.
In particular, I think the only situation where you would want, like for a personal Bitcoin setup, where you're running multiple copies of the same version, your primary reason for that is probably redundancy, not for validating that it was working correctly.
Well, here's a perhaps direct example.
Unless it's a different architecture.
Yeah, that's true. I'm a Bitcoin developer. I work on Bitcoin-like things, and I have a couple of patches that I maintain for my own daemons that support extra RPCs and such. Mostly not consensus code if it's something that I'm using with my own money. But nevertheless, I am running these, and this is my wallet that I would use for some application. I would still gate that through a vanilla Gideon-built Bitcoin Core that does block relay towards it. Simply because I don't want some mistake I made, which I possibly do, to affect my own funds. So by having the gateway, it helps you both ways in terms of making sure you're in sync with the network, but also making sure that any transaction you broadcast, it might get not relayed beyond that node that you were connecting to.
I can give a concrete example of, like one of the top 5 custodians in the world is using Bitcoin primarily, but they're not crazy enough to expose that like directly to like the outside world with public connections, and they use only Bitcoin Core as edge routers to protect their own implementation, and they verify against both for everything.
Yeah, I know at least 2 major mining pools have a ladder of Bitcoin Core versions, and they source work from the bottom of the ladder and then work your way up to all the different various releases to the eventual edge node that's connected to the network. This ensures that any blocks that they mine are known to all versions of Bitcoin Core and are likely to be accepted. And it would prevent them from being on the bad side of a fork that might get reorged out when .19 and .18 diverged.
All right. Are there any more questions? Not, then let's thank our panelists.
Okay.